Hello friends, I'm Imogen, and today I'll be reading Steve Donahoe's blog post called Room for All Types of Beekeeper, which appeared on the Walrus and the Honeybee on the 26th January 2025. Steve noticed that his most downloaded podcast episode was read by me, as I have a perfect voice, whereas he is a flawed biological life form. So I'll do my best to live up to my growing reputation. Anyway, relax and listen. Here goes. I went and bought Genetic Priorities for Conservation of Native Honeybees by Dorian Pritchard, one of the big voices in an area of beekeeping that is foreign to me. It seems well produced and has some interesting ideas, but I find the logic a little confused. But maybe it's just me who's confused. I wanted to try to understand why emotions run so high when the subject of black bees arises, and why commercial beekeepers and queen breeders are viewed by some as destructive and negative forces. In this article, I shall compare the type of breeding advocated, but not always followed, by Mr. Pritchard, natural selection, with modern queen breeding, in which humans engineer certain traits into the bees. However, the confusion I have needs to be explored first. There are two main arguments put forward about Apis mellifera mellifera, the black honeybee, which many consider to be the native bees of Northern Europe. The whole idea of native anything is somewhat flawed, in my view, but that's another matter. The first argument, and one I subscribe to, is that Apis mellifera mellifera is a subspecies with a unique history and set of traits, and it should be conserved. It should not be allowed to disappear. That's the conservation argument, and who could disagree with it? I love black bees, and the other types too. It would be tragic to lose them. Given the importance of conservation, I would support protected areas being set up, backed by legislation, similar to what happened with Colonsay in Scotland. I don't believe there are any legally protected black bee sanctuaries in England. The one in Mount Edgecombe in Cornwall does not appear to have legally protected status, but I could be wrong. It's also tiny. As far as I know, anyone could pull a load of buckfast bees down in that area without breaking the law. However, I believe that the beekeepers on that peninsula are of the same mind and are keen to preserve the Cornish black bee. Without designated legally protected areas, at least in much of England, there will always be the typical mongrelization going on, if that's a word. Many beekeepers prefer different types of bee, and they have every right to keep them. The second, and much harder to agree with argument, is that mellifera evolved over thousands of years to be the perfect honeybee for our country, so anything that is not mellifera mellifera must be less good. From this, it is a small step to say that we should really only keep black bees, even though, in truth, a 100% pure black bee is about as common as hen's teeth. Bees of different subspecies freely interbreed, and this has led to most bees in England being mongrels. It doesn't make them bad bees, but they are a mixed bag. Many believe that we should try to get back to the black bee by only allowing bees of the native type, meaning no ginger coloration on the bodies of the bees, to propagate. That, of course, is not natural selection. But apparently, that type of human intervention is okay because it is an attempt to get back to what nature created in the past. Jurassic Park, anyone? There is a clash between allowing nature to take its course and trying to recreate a land of native bees. When nature takes its course, in my area at least, you get mongrels. In Northumberland, the black bees do very well by many accounts, and natural selection seems to prefer them, which is great, but we don't all live in Northumberland. While I'm on the whole nature versus nurture subject, humans are part of nature too. We have had a profound, generally detrimental impact on our planet, but we are part of nature. The imports of bees at various times have not all been negative. Mongrel queens head many great colonies. Beekeepers across the country were desperate for imported bees after the Isle of Wight disease because they had some resistance to whatever caused that particular plague. Anyway, I hope I have established that ensuring the ongoing survival of Apis mellifera mellifera is a good thing, which I support. I think that Sue Coby has provided a template that could be followed. Her methods incorporate instrumental insemination to enable selective breeding of certain beekeeper-friendly traits into her closed population of Carniolan bees. I don't have a problem with that, but there is a school of thought that such interference can weaken the bees. whereas allowing nature to take its course leads to ideal diversity and adaptation. Let's look at some outcomes of human meddling with nature to bend it to our will. The wild ancestors of our domesticated cows were the aurochs. They roamed across Europe, Asia, and Africa, and were hunted extensively by humans, and plenty of other things, I imagine. In the Near East, they were domesticated about 8,000 to 10,000 years ago, as humans transitioned from hunter-gatherers to farmers. A similar situation applied to pigs, who descend from wild boars. They occupied similar land masses and were domesticated at a similar time. At least wild boars still exist, whereas aurochs are gone. It's the same story again for sheep, who descend from mouflon, which are still found in some parts of the Middle East and Asia. One thing that stands out about the difference between the wild and domesticated versions of the above livestock is the size of their horns. They are much smaller in most of the domesticated breeds. The original wild chickens were the red jungle fowl, a native of Southeast Asia, which still exists today. The ancestors of these modern animals were gradually domesticated through selective breeding to produce traits beneficial for farming, such as tameness, higher productivity, and adaptability to human-controlled environments. I can't exclude my favorite breed of dog, can I? Like all dogs, beagles descend from grey wolves, who were domesticated as far back as 20,000 to 40,000 years ago. Early domesticated dogs were selectively bred by humans for specific traits, such as hunting ability, size, and temperament, giving rise to various breeds. The beagle's lineage traces back to hunting dogs in ancient Greece and Rome, where small, scent-oriented hounds were bred to track game. They are cheeky and cute, but also very useful for sniffing out drugs or explosives at airports. So selective breeding, it's what we do. For some reason, some people frown upon selective breeding of honeybees, unless it's to try to backtrack to a more pure example of black bees. Weird. What it boils down to is whether the selection is being done by nature, meaning the environment, or humans. Modern commercial bee farming is a cornerstone of the global agricultural and ecological framework. At its core, it involves the large-scale management of honeybee colonies for honey production and pollination services. In parallel, the practice of selectively breeding honeybees has become the norm for improving traits such as docility, high honey yield, and disease resistance. However, an alternative approach exists, allowing natural selection to shape bee populations without direct human-driven breeding. With natural selection, environmental pressures dictate which bees survive and reproduce, potentially leading to more robust, genetically diverse colonies. I think that we will never be able to get away from bees doing what they do and reproducing by swarming. We will always have natural selection going on, and across most of the UK, there is a great intermingling of bee genetics taking place in a very natural way. Good things about bee farming. Commercial beekeeping is a significant contributor to Europe's economy. Honey, beeswax, royal jelly, and propolis generate substantial revenue. Beyond these products, managed bees provide crucial pollination services. Crops such as almonds, apples, oilseed rape, mustard, and borage rely on honeybees for optimal pollination, supporting both local food production and export industries. This synergy between pollination and honey production provides livelihoods for beekeepers and growers. One might call it a win-win. Of course, pollination will happen without honeybees. There are lots of pollinators. For the growers, it is very convenient to be able to have large numbers of honeybees visit their crops exactly when needed and be removed afterwards. Crop yields can be increased by 10% plus using the right number of honeybee colonies per hectare. That's an increase above what local wild pollinators would achieve. Some negatives. Miticides. The varroa mite stands out as a major threat to honeybee colonies. While miticides have proven effective in controlling these pests, they can cause unintended consequences. Chemical residues can accumulate in wax, creating potential sublethal stress for bees. Over-reliance on synthetic treatments like amitraz can also accelerate mite resistance, necessitating stronger or more frequent chemical interventions. Without rotation of treatments, using organic acids or essential oils, it is likely that the efficacy of amitraz will wane. Going treatment-free is not normally considered viable, as so many colonies would die in the first few years, and bee farmers would lose their livelihoods. Reduced diversity. Although selective breeding can produce bees well suited for particular environments or markets, it may inadvertently narrow the genetic pool. A reduced gene pool can make colonies more vulnerable to emerging diseases, environmental changes, or other stresses. The focus on a few commercially favored strains risks overshadowing the ecological and genetic contributions of local or wild bees, which may harbor valuable traits such as hardiness or unique foraging behaviors. This is why conservation is a good idea. However, the breeders are not idiots, and the degree of diversity across UK honeybees remains high. Although many queens are purchased each year by beekeepers, the majority of colonies are headed by diverse homemade queens. Competition with wild pollinators. High-density apiaries can create intense competition for floral resources, particularly if placed in sensitive or already resource-limited habitats. Native pollinator species may be overshadowed, potentially leading to shifts in local plant-pollinator relationships. Furthermore, large-scale commercial movement of bee colonies, migratory beekeeping, may spread pathogens to other honeybees or even other species such as bumbles. Many European countries have recognized the importance of apiculture and have introduced policies to support beekeepers. These might include subsidies for equipment, training programs in disease management, and research funding for selective breeding initiatives. The European Union's regulatory framework on pesticides, for example, is partly shaped by concerns over pollinator health. Many pollinators have suffered from population decline, but the honeybee isn't one of them, despite frequent reports to the contrary. Goals and methods of selective breeding. Selective breeding in apiculture focuses on honing desirable traits. Just like creating the perfect dog, the beagle. Key objectives often include high honey production, gentle bees, low swarming propensity, disease parasite resistance, e.g. hygienic bees, and bees with some degree of varroa resistance, meaning they have the ability to reduce the mite's rate of reproduction. Breeding programs typically involve controlled mating by isolating queen bees and introducing them to selected drones. In Europe, very sophisticated breeding programs have been running for many years, often utilizing island or peninsula locations in Denmark and Germany for mating. Brother Adam achieved isolated mating at Sherborton on Dartmoor. Artificial insemination is also employed in some research and commercial settings, ensuring that queens receive genetic material from pre-chosen drone lines. It's precisely what we have done with agricultural livestock and crops, and what many people benefit from in their flower gardens. Natural selection. In contrast to human-led breeding programs, natural selection in wild or feral bee populations works by testing each colony in its local environmental conditions. The survival and reproduction of colonies depend on their inherent adaptability to threats, disease, climate, predators, and more. Colonies that survive pass on genes that have proven robust under these pressures, gradually enhancing population-level resilience. Over many generations, this process may lead to populations with greater genetic diversity and resilience. However, it also involves more significant short-term risks, as colonies unsuited to local conditions simply perish. Mike Palmer, who has very long and cold winters in his apiaries in northeastern USA, believes his winters are great at weeding out weak or unsuitable genetics. Dorian Pritchard believes the same, and advocates no hive insulation so that the bees are forced into a tight cluster with a brood-free period. I can see their point, although personally, I insulate the tops of my wooden hives to prevent condensation from forming and dripping onto the cluster. To be honest, winter in my area is quite mild, so it's not putting much selective pressure on my bees. Advantages of natural selection. Greater genetic diversity. Feral colonies adapt to local conditions in a myriad of ways, often leading to a broad genetic base. However, in the case of varroa mites, allowing most colonies to die by not treating them will mean a genetic bottleneck, as only maybe 5% survive. In hundreds of years, that may not matter, but in the short term, it's devastating. Resilience and disease resistance. Without chemical or human intervention, only colonies with strong natural defenses survive, helping to propagate those resilient traits. Ecological balance. Natural selection-driven bees may be better attuned to local flowering cycles, potentially enhancing pollination efficiency in native ecosystems. Downsides to natural selection. Reduced honey yields. Bees that prioritize survival traits may not always be top honey producers. They may, in fact, be highly prone to regular swarming and small colonies, meaning small amounts of excess honey for the beekeeper. Unpredictable temperament. Bees selected by nature rather than by breeders for docility can be more defensive. Black bee evangelists claim that defensive behavior comes by crossing with evil foreign bees. I am pretty sure that bees left to their devices become more defensive than bees specifically bred for docility. Short-term colony losses. Widespread mortality may occur initially, especially when new pathogens or pests strike, because no chemical interventions are employed to cushion the blow. The species or subspecies may survive, but there will be peaks and troughs in populations as challenges strike. Boom and bust is not uncommon in the natural world. Conclusion: modern commercial bee farming offers tangible economic and agricultural benefits. By harnessing selective breeding, beekeepers produce colonies that are high-yielding, docile, with low losses, meeting the demands of a growing agricultural sector while ensuring a steady supply of hive products. There are a lot of humans to feed, and food producers need all the help they can get. This approach can also reduce genetic diversity and exacerbate dependencies on chemical interventions. It's about striking the right balance. Allowing natural selection to guide bee populations may foster robust, genetically diverse colonies that are inherently better adapted to local environmental conditions. While this strategy can sacrifice short-term productivity and predictability, it offers potential long-term gains in resilience and ecological harmony. But will it satisfy the humans that want plentiful and varied foods at low prices? A balanced perspective seems to be that selective breeding and natural selection need not be mutually exclusive. Many apiculture experts advocate soft breeding approaches, where bees are selectively bred, but with room for local adaptation and minimal chemical inputs. I think there is room in the UK for all types of bees and beekeepers. Given the degree of genetic mixing that has already taken place, the only hope for the conservation of pure examples of the various subspecies is through the creation of protected areas, where other bees are excluded. Creation of such places would be a positive thing, whereas infighting between beekeepers is negative and futile. Okay, so that's the end of Steve's blog post. Some food for thought, I think you'll agree. If you enjoyed this episode, please share it with anyone you know that might also like it. Thanks so much. Have a great day.